This is Mission Control Houston. PDRS officer here in the flight control room confirming that for all practical purposes, the telescope is in the low hover position, and Mission Specialist Steve Hawley just doing some minor tweaking to adjust its posture above the payload bay. The next RMS maneuver after some commanding from the stock will be the transition to a 90-degree roll position, followed by the move to high hover.
Discovery, we see you at low hover. No need to acknowledge. We are commanding the DCE, MCU command groups.
Roger that.
This is Hubble Telescope Control, Greenbelt, 1 day, 31 minutes mission elapsed time. The orbital verification team is right now in the process of taking the first step toward deploying the Hubble's two 40-foot long, 8-foot wide solar arrays. The team is sending commands to power up the deployment control electronics aboard the spacecraft. This is an internally redundant black box that controls the deployment and retraction of the solar array wings and monitors the status of the deployment mechanisms as that activity is underway. Specifically, it monitors such things as deployment motor temperatures and solar array blanket tension. The secondary deployment motor temperatures must be at least 32 degrees Fahrenheit and not more than 78 degrees Fahrenheit prior to starting a deployment. Additionally, tension on the wings should not exceed 10 pounds during deployment. There are two methods should there be a problem with excess tension on the wing to stop deployment. It can be stopped from here in the control center should that become necessary. Additionally, the crew has the capability on board the orbiter to visually monitor the tension and stop deployment. Orbital verification team in the process of sending those commands. It's a three-step process, and it'll take approximately 5 minutes to complete the first set of commands to turn on the deployment control electronics. Once that's completed, the team will begin commanding the configuration of the mechanisms control unit. This also internally redundant electronics which actually control the motors, the latches, and the hinges for the solar arrays, high gain antennas, and the aperture door. Things looking good as we continue to step through this process of activating the deployment control electronics. Meanwhile, we're continuing to receive downlink television of the Hubble telescope at the end of the remote manipulator arm. Visible is the underside of the telescope for the first time, and to the right of the field of view is the starboard solar array wing in its stowed configuration running parallel to the light shield on the telescope.
Go ahead, Charlie.
Story, we're up to the point of the biomed UHF comp checks with the EV guys, but what we'd like to do, provided EV concurs, is we'd like to hold until we get the telescope up to one of the long-standing positions and then we'll get that in. And that I think that way we won't be working too many things at once.
EVA says that's fine, Charlie.
Okay, thank you.
And this is Hubble Telescope Control. The orbital verification team has confirmed that sequence 20, activation of the deployment control electronics, was successful. And they are proceeding with the first step in the next sequence, which is to configure the mechanism control unit. Those commands now on the way to the spacecraft. The mechanisms control unit is kept off until the telescope has been placed in a low hover position by the mission specialist, Steve Hawley, and this is done to prevent the premature deployment or inadvertent deployment of the appendages while the vehicle is in the payload bay. Orbital verification team continuing to step through activation of the mechanisms control unit without any problems. It's going very smoothly at this time. Continuing to receive downlink television of the telescope in the low hover position. The most of the yellow rails running both along the and across the axis of the telescope are handrails. They are crew EVA rails that would be used should the crew need to do an EVA during deployment, and also during servicing missions, which are scheduled periodically throughout the 15-year life of the Hubble telescope. Also visible in the field of view is the second high-gain antenna, through which high-rate science data will be passed to TDRS, to White Sands, and on to the Space Telescope Operations and Control Center and the Space Telescope Science Institute once the telescope science instruments have been activated. For reference, we're looking at what is normally would be considered the top of the telescope, the hinged. It's the side of the telescope where the aperture door is hinged, and visible in the top of the field of view is the hinge mechanism for the telescope.
This is Mission Control Houston. As indicated by live television downlink and telemetry watched here in the flight control room in Houston, Mission Specialist Steve Hawley has begun to very slowly roll the Hubble Space Telescope along its longitudinal axis to set up the maneuver to high hover. The 90-degree roll will do a couple of things. It will protect the fixed head star trackers. It will produce a more favorable position in relation to the robot arm for the move to high hover, and we'll set proper axes for pitching the aperture door end of the telescope down into the payload bay and around to the solar array deploy position.
This is Hubble Telescope Control Greenbelt as Steve Howley continues to work with positioning of the Hubble telescope. The orbital verification control team here in Greenbelt is sending a series of commands to switch the solar array secondary deployment motor heaters off. Those heaters were turned on a little bit less than an hour ago in the blind. Now that we are able to monitor temperatures, we have an indication that the temperatures of the motors are slightly above the 25 degrees centigrade or 78 degrees Fahrenheit. So we're going ahead and switching those heaters back off at this time. Those commands are now being sent to the telescope. Otherwise, everything going very smoothly here at the Space Telescope Control Center. Things about to get very busy once the crew of Space Shuttle places the telescope in the appendage deploy position. As next couple of hours, there will be numerous commands sent to begin deploying the arrays and the high-gain antennas and preparing the telescope for release. At 1 day, 43 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt. And this is Hubble Telescope Control, Greenbelt. The Director of Orbital Verifications has advised Payloads Officer Nellie Carr in Mission Control that we have successfully reconfigured our secondary deployment motor heaters to the off position. And we're now standing by for notification from Mission Control that the telescope has been placed in the high hover position, at which time we'll begin our actual deployment of the arrays with the latch releasing, releasing the latches that hold the arrays to the side of the telescope in the stowed configuration. At 1 day, 45 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt.
This is Mission Control Houston as Discovery tracks high out over the southwestern portion of the African continent. Steve Hawley continuing to roll the Hubble Space Telescope along its longitudinal axis to a 90-degree roll position, which will set up the final sequence of maneuvering the telescope to the appendage deploy position, which will consist of first an elevation of the telescope to the high hover position, followed by a pitch around of the aperture door end of the telescope down towards the payload bay and then aft towards the OMS pods. Once in that position, the telescope operators in Greenbelt will be given a go to begin driving the mechanisms on the telescope. During those mechanical sequences, the crew aboard Discovery will take the digital autopilot, which controls the attitude of the vehicle in orbit, to free drift, allowing Discovery to drift without reaction control system thrusters firing in order to avoid any perturbations on the appendages as they're being driven. Once the appendages are locked into position and the control team here has confirmation from the stock that that's been accomplished, then Commander Lawrence Shriver will then tweak the attitude back to the desired solar inertial attitude and then give a go for continued mechanical sequences going back to free drift. That sequence will repeat itself a number of times while the telescope operators drive those arrays and appendages into place. But at this time, we're watching as Hawley continues the roll maneuver on the telescope, setting up the final stages of positioning for the appendage deploy sequence. Discovery now just about 16 minutes away from tracking into darkness, and just a couple of minutes very shortly thereafter passing out of range of the tracking and data relay satellite east for a short loss of signal period of about 4.5, 5 minutes. Again, all systems aboard Discovery continuing to perform very well in support of nominal deploy operations today. Flight controllers here on the ground continuing to watch joint motion and RMS drive rates, and everything continuing to look very nominal as far as RMS operations go. We'll continue to take continuous live downlink television through the Eastern Satellite KU-band system throughout deploy operations today, as line of sight porting with the TDRS satellite permits. We expect to lose this signal with loss of line of sight of the tracking and data relay satellite east about 10 minutes from now. Our next expected live downlink television will come at about 9:16 a.m. Central Time as we acquire signal again through the Eastern Satellite on orbit 17. Again, Hubble Space Telescope deploy operations continue to progress without problem at mission elapsed time 1 day and 50 minutes. This is Mission Control.
Discovery, we're about 2 minutes from Tidris LOS. Pick you up in about 6 minutes, 1 hour and 4 minutes. We see you on the way to high hover.
That's firm, Houston. On the way to high hover.
Okay, Lauren.
This is Mission Control Houston. We're just about a minute away from passing out of range of the tracking and data relay satellite east, and as we do so, Discovery and its Hubble Space Telescope beginning to pass from day into darkness. Mission Specialist Steve Hawley has succeeded in rolling the Hubble Space Telescope 90 degrees around its longitudinal axis, is in the process right now of elevating the telescope position to a high hover. Again, that's adjacent to the low hover position, but several feet higher to allow for clearance of the telescope when he begins the pitch down maneuver to pitch the aperture door end of the telescope down towards the payload bay and then back towards the OMS pods, which will set the stage for solar array deployment. After a short loss of signal period of about 4.5, 5 minutes, we'll acquire again through the western satellite. Again, we don't expect to see any more live downlink television until about 16 minutes after the hour, 9:16 Central Time. And until then, we'll be continuing to watch live telemetry from the vehicle as Hawley continues RMS operations to place the telescope in the proper solar array deployed position. At 1 day, 59 minutes, this is Mission Control.
This is Hubble Telescope Control Greenbelt, 1 day, 1 hour, 1 minute mission elapsed time. The orbital verification control team here in the mission operations room is postured to begin deployment of the solar arrays, which will begin with releasing latch mechanisms that hold the solar arrays in their stowed position along the side of the Hubble telescope during launch, followed by activation of motors which will drive the masts to which the solar arrays are attached out perpendicular to the telescope, and then the commands will be given to begin unfurling the array blankets one at a time. This is a very high activity period here at the Goddard control facility, and the Lockheed control team has a double shift on for this critical period. Shift supervisor for the deployment period is Pete Patero, and he is also assisted by shift supervisor Harry Wynn. The control team is responsible to the on-duty Goddard Mission Operations Manager during this period of time, who is Dick Moore. commands will be built and actually sent to the spacecraft by Ops Controller Larry Williams and Ops Controller Tim Perry. Again, all is in ready here in the Hubble Space Telescope Operations Control Center, Greenbelt, Maryland, to begin sending critical commands to the telescope to begin deploying the solar arrays and then later the high-gain antennas in preparation for today's release of NASA's Hubble telescope. 1 day, 1 hour, 4 minutes mission elapsed time. This is Hubble Telescope Control in Greenbelt.
Discovery, we're back with you.
Roger, Houston, loud and clear.
The same, Kathy.
This is Mission Control Houston. Mission Specialist Steve Hawley has successfully maneuvered the Hubble Space Telescope to the high hover position, as it at this time beginning to tweak the alignment of the telescope in preparation for the 90-degree pitch that'll point the aperture door end of the telescope directly into the payload bay before continuing on to the solar array deploy attitude. Again, all systems aboard Discovery continuing to perform very well. We're pressing on with a nominal Flight Day 2 deploy timeline, and telemetry seen here in the flight control room already beginning to indicate that Hawley has begun the 90-degree pitch around maneuver.
And this is Hubble Telescope Control in Greenbelt. we have been given the go-ahead to begin commanding release of the forward latches, which hold the solar arrays in place during launch along the side of the telescope. The forward latches are on both sides, both the port and starboard side of the telescope are released simultaneously. The latches are operated by electric motors. Latch release is a fairly slow process. Latches are fairly beefy mechanisms, and it takes about a minute for the latches to move from the fully closed to the fully open position once the actual command to drive those motors is given. There's some preparatory commands that are sent up to do some last-minute configuration prior to actually driving those latches. Each of the solar array wings has two latches, actually, a forward and an aft latch, which are used to hold the wing stowed to the side of the telescope while it's in the payload bay. The team is in the process of sending the commands to start those motors, and we'll stand by for an indication from our telemetry here that the motors are in motion. And this is Hubble Telescope Control. We have indication that we're approximately 1 minute now from releasing the forward latches.
Discovery, we're 1 minute from releasing the solar array forward latches.
Roger, Houston, 1 minute to solar array forward latch.
Confirmed, Kathy.
This is Hubble Telescope Control. We now have indication from our data here in the control room that the motors are in operation to drive the forward latches open.
Discovery, no need to acknowledge. The forward latches are in motion.
Roger, Houston, we copy.
good news. Data indicates that both the port and starboard wing forward latches have moved to the open position. Standing by now for confirmation. And this is Hubble Telescope Control, 1 day, 1 hour, 14 minutes mission elapsed time. We have confirmation now that the forward latches are indeed open.
Discovery, the SA forward latches are released.
We copy story. Forward latches are released.
Confirm, Kathy.
And this is Hubble Telescope Control. The next commands that will be sent from the control center here will be to release the aft latches. We will need to be in a free drift configuration when this is done, because these are the primary load-bearing latches, and there is a desire not to have the reaction control system enabled, because there would be a concern that perhaps loads induced into the latches, should that system fire, might cause problems with the telescope aft latches. Therefore, prior to doing that, we will wait for the crew to ensure that we are in a free drift configuration. 1 day, 1 hour, 16 minutes mission elapsed time. This is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston. Mission elapsed time, 1 day, 1 hour, 17 minutes. Mission Specialist Steve Hawley has driven the remote manipulator system to position the Hubble Space Telescope now in the 90-degree pitch position, with the aperture door end of the telescope pointing directly down into the payload bay. After reloading some targets into the robot arm computer, Hawley will drive it on to the solar array deploy position, which roughly points the aperture door end of the telescope towards the OMS pods, the aft end of the vehicle. And we're continuing to watch on NASA Select Television live digitally generated animation based on real-time telemetry from Discovery in orbit. Although the Tracking and Data Relay Satellite West has KU support available for this period of the flight, due to the solar inertial attitude that the vehicle is in at this point, we have KU band blockage and are unable to bring that television in. So until we require live television again in about 35 or 40 minutes through the the eastern satellite, we'll continue to look at this animation, which is modeled based on, again, real-time telemetry from the orbiter Discovery. Once the telescope is placed in the solar array deploy attitude or position, the next step will be, of course, to confirm the readiness of the telescope operators to begin the mechanical sequences, releasing the aft latch and deploying the solar array mast. Once that confirmation is given, the crew will be given a go to take Discovery to free drift, and again, to avoid any perturbations or effect on the telescope that might come from digital autopilot firings of the reaction control system on board the vehicle. While the orbiter is in free drift, we expect it to drift at a very limited rate, very slowly out of its solar inertial attitude. And once the mechanical sequence is accomplished and confirmed by the stock, Shriver will be given the go ahead and tweak that attitude back up. And we'll repeat that process several times until both masts and solar arrays have been deployed and unfurled, and then maneuver to the appendage deploy attitude for driving the high gain antennas into their deploy position. This is Mission Control Houston, the PDRS officer here in the flight control room watching telemetry on the ground confirms that Hubble Space Telescope is now in the solar array deploy position. Standing by for a coordination with the crew and with the telescope operators in Greenbelt, Maryland to begin the free drift and mechanical sequences.
Houston, Discovery telescope is at the attendance or solar array deploy attitude.
We see that too. Thank you, Lauren. We'll be getting commands together to enable DC motor group 5.
This is Hubble Telescope Control Greenbelt. 1 day, 1 hour, 25 minutes mission elapsed time. Shift Supervisor Pete Patero has just confirmed that the operations team is ready to begin commanding the aft latches, holding the solar arrays to the side of the telescope to the open position. And this is Hubble Telescope Control, Greenbelt, 1 day, 1 hour, 28 minutes, mission elapsed time. The orbital verification team has begun loading the commands and sending commands to the telescope to open the aft latches. The initial commands that are going forward are configuration commands, and once we get to the point where we're actually sending the commands to drive the motors which operate the aft latches, then the Director of Orbital Verification will advise Houston payloads that we're ready for the crew to place the orbiter in free drift. Again, initial preparatory commanding is now underway to open the aft latches and the final set of latches that hold the solar arrays to the side of the telescope.
Discovery, go free drift for solar array aft latch release in about 15 seconds.
Roger, free drift.
Confirm.
Free drift is there.
Thank you.
And this is Hubble Telescope Control, Greenbelt. We're standing by now with that call from Story Musgrave to the crew to begin commanding the motors open as soon as the vehicle is in free drift. And this is Hubble Telescope Control. We have confirmation from the orbital verification team that the motors driving the aft solar array latches to the open position are operating.
Discovery, while you're in free drift, we'll be pressing right along for PDM deploy. We'll give you a call a minute prior to expected deploy.
Okay, Story, thank you.
In Discovery, your aft latches are moving.
And this is Hubble Telescope Control, Greenbelt. We're receiving initial telemetry that shows that both the the starboard and port solar array wing aft latches are in the open position. The latches open at 1 day, 1 hour, 32 and a half minutes mission elapsed time. With the release of those latches, the solar array's primary deployment mechanism is free from the side of the telescope. Our next step will be to drive motors that will swing the deployment masts away from the side of the telescope to a position that's perpendicular to the telescope.
Discovery, the solar array aft latches are released. We're pressing on with PDM deployed.
We copy.
Discovery, could you go auto Verns? We're not going to command here until we get Teeter's handover.
Roger, we'll go back auto burn.
Thank you.
This is Mission Control Houston. As Discovery has been in free drift for the last several minutes, awaiting the beginning of the deployment of the solar array masts. Discovery has drifted somewhat out of attitude, and with a handover from the tracking and data relay satellite west to the eastern satellite in just a few minutes.
And Discovery, we'd like free drift now.
Roger that. You got a pretty good roll rate going in negative direction.
Yeah, you can stop the roll rate.
We're going free drift now. Storage, your copy, we're free drift.
That's a firm, Horn, and you might use some attitude maintenance to stop the rate and then go free drift.
Roger that.
This is Mission Control Houston. In order to avoid dropout in continuous live telemetry during the mass deploy sequence, decision was made to hold off on starting that mechanical sequence until after the TDRS handover is accomplished. In the meantime, Commander Lauren Shriver tweaking up the attitude a little bit to correct for some of the drift that's already been imparted in the vehicle's attitude while it's been in free drift, awaiting that command sequence for the last several minutes. In just a few minutes, we'll also be handing the satellite over to the Vandenberg tracking station and the Merritt Island station in Florida to bring some real-time television to Houston from the Space Shuttle Discovery. That will result in some non-standard signals broadcast on the NASA Select television transponder F2R transponder 13. Shortly after we've accomplished that downlink video transfer from the vehicle to Houston, we'll be back on the satellite with NASA Select and taking live KU band coverage through the TDRS system. Guidance and Navigation Officer here in the control room confirming that we're back in an attitude close to that we desire before going free drift and continuing with the mechanical sequences. And we're standing by for S-band audio, air-to-ground audio handover from the west satellite to the east, and a television handover to Vandenberg Station. At 1 day, 1 hour, 42 minutes, this is Mission Control.
Houston Discovery. We're watching the solar arrays, and we recognize that they move very slowly. Has motion started yet?
And Bruce, we just sent the commands now. It'll be about 1 minute to motion.
Roger, Story. Thank you. Houston Discovery, we see movement on the primary deployment mechanism.
Thank you, Lauren.
And this is Hubble Telescope Control Greenbelt. 1 day, 1 hour, 52 minutes mission elapsed time. Mission specialist Bruce McCandless has advised that they are seeing movement of the primary deployment mechanism. This motion will swing the 15-foot masts away from the side of the telescope.
And Houston, we still see good motion on the primary deployment.
Thank you, Lauren. We've got the TV down here.
Okay, good.
This Hubble Telescope Control Greenbelt, 1 day, 1 hour, 54 minutes mission elapsed time. Continuing to receive television through the Vandenberg tracking station, and it is clearly showing the deployment of the solar array masts with the solar array package in the stowed position. The arrays are wound much like a pair of window shades around a roller, and kept in that configuration for launch. And once the primary deployment activity has been completed, attitude and replaces the vehicle in free drift. The operations team here will begin commanding the solar array blankets to unfurl. The solar array masts are deployed simultaneously, both the port and starboard masts, and in the field of view is the port solar array mast being deployed. The actual blankets, however, are unfurled one set of blankets at a time. First set is the starboard, followed by the port blanket. The solar array masts are attached to the vehicle just below, or actually above, section of the optical telescope assembly. This houses the electronics packages for the telescope's optics, and directly in front of the arrays are attached directly in front of the equipment section for the telescope support systems module, which houses the other electronics for the spacecraft.
This is Mission Control Houston. At 1 day, 1 hour, 57 minutes, we're now taking live downlink television from the payload bay cameras aboard Discovery through the Merritt Island station in Florida. And again, simulcasting live on Satcom F2R with NASA Select Television. We're in the process of watching the solar array mast deployment on board the Hubble Space Telescope. The telescope is in the solar array deploy position, and the Discovery is in a free drift attitude mode, which allows it to drift slightly off of the desired orbiter attitude while those mechanical sequences are in progress. With mechanical sequences complete, Commander Lawrence Shriver will be given a go ahead and tweak the attitude back up before continuing on with the mechanical sequences to follow. Again, all systems performing very well. No issues being pursued in the flight control room here in Houston. Although we're just about 30 minutes behind the planned timeline for the array and appendage deployment sequences today, there's still no reason to expect yet that we will not be able to deploy on time as scheduled on Orbit 19 this afternoon about 1 o'clock. Timeliners and telescope commanders looking at their command plans, and there are opportunities between now and deploy time to cinch things up and get ahead.
It looks like the motion has stopped, and it looks like it's out.
Thank you, Lauren. We'll give you a confirmation when we get it.
telescope control greenbelt. 1 day, 2 hours, 1 minute mission elapsed time. We're standing by now for telemetry confirmation that both of the solar array masts are fully deployed. We're anticipating that momentarily.
And Discovery, let us know if you need added maintenance.
We will, Lauren.
Roger that.
As soon as we get confirmation of PDM deploy, we'll recover the attitude using auto burns, but not yet.
Roger, Story. And Story, on if you're looking at A camera, there's a phenomenal view of Florida behind HST.
We've been watching it, Steve. Terrific. Hubble's a beautiful sight with that background.
This is Mission Control Houston. We've lost our downlink television signal through the Merritt Island station in Florida. And as Discovery has been drifting slowly out of attitude, during this solar array mass deployment sequence, we have drifted into KU band blockage. So as soon as this mass deploy sequence is confirmed to be completed, we can have Commander Lauren Shriver tweak Discovery's attitude and regain line of sight pointing with a TDRA satellite and regain that television picture. In the meantime, flight controllers here in Houston standing by for confirmation from the telescope operators in Greenbelt that as to the status of the solar array mass deployment before pressing on in the sequence. At 1 day, 2 hours, 7 minutes, this is mission control.
This is Hubble Telescope's control, Greenbelt at 1 day, 2 hours, 9 minutes mission elapsed time. We are not receiving indications yet that the solar array mast have fully deployed. The crew indicated visually that they appear to be fully deployed. We have one indication at this time that we have reached the deployment position, and the analysts here are taking a look to determine if in fact we are at this point fully deployed with the primary deployment mechanism, the two 15-foot solar array masts. And this is Hubble Telescope control in Greenbelt. Because we're not receiving full deploy indication on the primary deployment mechanisms, the control team here in the Space Telescope Operations Control Center is in the process of sending some alternate commands to the telescope. This is a procedure that was designed pre-flight to deal with just such a situation. This will take us a few minutes at T-minus correction at mission elapsed time, 1 day, 2 hours, 11 minutes. This is Hubble Telescope control, Greenbelt.
In Discovery, we do not have confirmation that the PDMs are deployed. We'll get back with you.
Story, we understood you to say negative confirmation on PDM deploy, is that correct?
That's affirmed. On the plus side, we have neither the primary or the redundant indications of deploy. On the negative side, we have the primary but not the redundant.
Okay, we copy that. We're standing by.
And we're sending some commands right now to drive with both motors.
Roger, we copy.
Discovery, in order to preserve an orbit 20 release, we'd like you to get into EVA prep.
Okay, we're proceeding with that.
Thank you.
This is Mission Control Houston at Mission Lapse time, 1 day, 2 hours, 14 minutes, while Space Telescope operators in Maryland continue to troubleshoot the lack of confirmation of the solar array mass deploy. Flight controllers here in Houston have been assessing the time impact on EVA options for potential support of the deploy operation today, and determined that in order to preserve EVA support capability for an orbit 20 deploy, that the two EVA crew members, Kathy Sullivan and Bruce McCandless, ought to press on into the EVA prep timeline and begin donning the suits. Should the situation be resolved, they can be stopped in that activity until we need them to proceed any further.
Discovery, you can go. Auto Vern, we've got primary indications that both PDMs are deployed.
Okay, that's good. We're going primary burns and auto control.
Okay, Lauren,
Let's make that auto vernier control.
that's firm. Take you about 15 minutes to get back.
Roger that.
This is Mission Control Houston. That last air-to-ground exchange between Capcom Story Musgrave and
EVA
Discovery.
guys are getting set up for biomed comm checks.
EVA copies that.
And Crew Commander Lauren Shriver confirming that the stock team has seen good indication that the masts are locked, and Shriver has given the go to go ahead and tweak the attitude. He'll be selecting auto vern control to the digital autopilot, and take about 15 minutes to get back into attitude to proceed with the deployment of the solar array wings. In the meantime, Mission Specialist Kathy Sullivan and Bruce McCandless will continue into their EVA preparations in order to preserve the opportunity to support an Orbit 20 deploy with potential EVA support. As Shriver begins to maneuver Discovery back into attitude, we expect to reacquire line of sight pointing with the Tracking and Data Relay Satellite East, and thus our KU band TV signal, and within the next 10 to 15 minutes.
And Houston Discovery, just for your information, as we fire the verniers in the auto control mode, we see very, very, very minor movement at the end of the solar array boom. So it is just not hardly visible at all.
Thank you, Lauren.
This is Hubble Telescope Control Green Belt at 1 day, 2 hours, 19 minutes mission elapsed time. As Capcom's Dory Musgrave reported to the crew a short time ago, we do see now that both of our solar array masts are fully deployed. What occurred here in the control room was that the orbital verification team called up a malfunction procedure.
Houston Discovery.
Go ahead, Charlie.
Okay, Story, we've got them done in the comp carriers, and I'm going to reconfigure the biomed channels. In about 3 minutes, I'll be ready for a radio check with your initiation.
Okay.
And you should be getting biomed now.
We'll check.
And Story, you can go ahead and try it. I'm upstairs. I think they're dressed.
Okay. EVA crew, how do you read Houston?
Hey, Charlie, I heard the first word or two of Story's transmission, and then he dropped out.
And we're hearing you loud and
Okay,
clear,
let me get
Bruce.
him to try it again. And Houston, give him one more try.
Bruce, Houston's reading you loud and clear.
Okay, I read the words loud and clear, but only those words.
Okay,
time,
Bruce.
Mark.
And Kathy Houston.
Sorry, EV1, why don't you try again, please?
Okay, Bruce. Houston. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
I'm getting you about 50% of the time, Story. I got the Bruce Houston, then I got 4-5, and then something else.
And Houston from EV2, that's not an EV1 problem. It's common to the link. I'm hearing the transmission's the same.
All right, thank you, Kathy. I'll give you another count. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Okay, Story, I copied 1, 4, 5, and then 1 counting down again. I heard you on the mid-deck speaker for the intervening numbers.
Okay.
And for your info, Story, both EMUs are in PTT at this time.
Thank you. If you want any further counts, let me know.
I hear your transmission intermittently, Story. I'd have to assess that we've got about a 50% copy rate from you.
Okay, and is the orbiter crew getting me all the time?
Yeah, I can hear it on the mid-deck speaker even when you cut out on the EVA comm.
Yeah, that's affirmative, Story. We're getting both EV crewmen and Houston 5 by, although you are considerably weaker than they.
Okay.
And Story, EV2 still didn't copy anything from you about biomed. You verified biomed?
Stand by 1.
This is Mission Control Houston underway at this time. Our EVA communications checks using the communications gear that will be used by the EVA crew members once they're in their suits. And we're standing by for some tweaking and reconfiguration of some ground equipment that affects the uplink voice before trying those comm checks again. Again, mission specialists Kathy Sullivan and Bruce McCandless are pressing on into the EVA preparation procedures in order to preserve the option for EVA support of deploy operations today due to the lag in the timeline. We're now taking live downlink television through the Tracking and Data Relay Satellite East KU band system. And the limb of the Earth coming into the right portion of the field of view as Commander Lauren Shriver continues to maneuver Discovery back to the preferred solar array deploy attitude. And Discovery now on the descending node of orbit 17 just off the South Atlantic coast of Africa. Again, we're standing by for some reconfiguration of some ground communications equipment before reattempting communications checks with the EVA crew members via their EVA comsets in the mid-deck of Discovery.
And we'd like like to do another comm check with EVA crew. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Hey, Troy, that sounded a little better, although the first words, I'd like to do another comm check with the EVA crewman, came only over the mid-deck speaker. They did not come over the RF link to us.
Okay, Bruce.
And Story, any luck on the biomed?
We do not have it yet. I'll check again. Charlie, we still do not have biomed.
Bad Story, I guess unless you guys think you're going to find something here in the next few minutes, we're thinking that perhaps we ought to just go ahead and terminate the checks and so we can get the units back off.
Houston for Charlie.
Go ahead, Story.
The only suggestions we got are to, cycle the connections, the pigtails on your signal conditioners. We have no other ideas.
Okay, I'll have them do that one more time. And I'll go up and recycle the biomed channel selectors.
Yeah, and it's not likely we wouldn't be getting both of them, but that's the only suggestion we have.
completed the cycle on the Biomed channel selects, and I think Bruce and Kathy have completed disconnect and reconnect on the pigtails.
Copy, Charlie.
And Houston, that's close to correct. EV2 is now hooked back up. EV1 is in work.
Okay, Kathy.
Okay, Story, I'm back online. I have disengaged and re-engaged each of the three connectors in the Biomed loop.
Discovery, we still have no biomed from either crew member. I think you've done all you can.
This is Mission Control Houston at 1 day, 2 hours, 33 minutes. Discovery has reacquired the solar array deploy attitude and is ready for confirmation from the telescope operators that they're ready to press on with the mechanical sequences and going back to free drift to accommodate that. Flight controllers looking at the timeline implications from the
Discovery,
delays
we found a problem
we've
on the
encountered
biomed.
this
The
morning,
current TFL does
and
not support
coordinating
biomed.
the
We'd like you
mechanical
to press on
sequences.
from here.
At this point, while folks are looking with a watchful eye to the possibility of an Orbit 20 release, which it would be one orbit later, planners have not yet abandoned the real possibility of making the release on time simply by moving some of the sequences and the commanding procedures up in the timeline a little bit. In the meantime, EVA crew members will continue to prepare EVA equipment for the possibility of supporting deploy operations should it become necessary. The solar array masts are in place, and at this point we'll be pressing on with attitude maintenance to support the unfurling of the arrays. Assuming that can be conducted in the time we expect, there are some good opportunities for cinching up some of the remaining commanding and still preserving an Orbit 19 release. The orbiter Discovery now crossing the terminator from day to dark to the dark side of the Earth at orbital altitude of 330 nautical miles just off the southeast coast of the African continent. We're also just about 7.5 minutes away from losing signal through the tracking and data relay satellite east. We'll have a short loss of signal period, about 4.5 minutes, before acquiring again through the western satellite. And some 20 minutes or so after that, when we move back into the part of the orbit, begin the next mechanical sequence. So between now and then, Shriver will maintain attitude with the digital autopilot in the auto-burn mode. And once we reach daylight period again and can continue with the mechanical sequences, we'll be giving Shriver the go to go back to free drift and the stock a go to command again. Still encountering some difficulties in establishing clear communications with EV crew members through their EVA communication sets, but not enough to preclude continuation of EVA preparation. So the crew is going to press ahead in the EVA preparations, and while people continue to troubleshoot the problems that we've had with voice dropouts. All systems aboard Discovery continuing to work very well in support of deploy operations. No issues being followed here in the flight control room in Houston other than looking at some timeline options to preserve the Orbit 19 release. And Lead Flight Director Bill Reeves is pulling the troops here to see if we have any messages for the crew before losing signal in just a few minutes. At 1 day, 2 hours, and 37 minutes, this is Mission Control.
Houston Discovery. Houston Discovery.
Go ahead, Charlie.
Yes, sir. Just clarification, Story. We're at just finished step number 19, and we wanted to know if you want us to continue on.
No, you can stop right there, Charlie.
Okay, we're gonna hold at 19.
That's affirmed, and all the Hubble stuff, we will pick all that up again as soon as we get daylight. And Houston for Lauren. Yeah, we'd like you to interconnect left ohms to RCS. It's in orbit pocket, page 8-3.
Okay, we copy interconnect left ohms to RCS, orbit pocket.
That's firm.
Houston Discovery.
Go ahead, Lauren.
After opening across these valves, our left and right fuel manifold pressures are less than 130, and we need to check with you.
We were just about to get up with you. You're still got to go for the interconnect.
Okay, we copy.
Discovery, we're a minute to Tidris LOS. Pick you up at about 2:48.
Roger, 248. Sorry.
And we'd like your interconnect, Lauren.
Okay, thank you.
This is Hubble Telescope Control, Greenbelt 1 day, 2 hours, 43 minutes mission elapsed time. The orbiter has passed out of range of the tracking and data relay satellite. Will reacquire in approximately 4.5 minutes. Fairly busy pass, not only in Houston, but here in the Space Telescope Operations Control Center, as well as the control team deployed the primary deployment mechanisms for the solar arrays. This activity took a bit longer than anticipated because the control team could not receive an indication that both of the masts, the 15-foot masts, were in their fully deployed position. As a result of that, there is a pre-mission procedure, alternate procedure, which was used to command those masts to the deployed position. Basically, that entailed switching from the primary to the redundant deployment control electronics box, and using the redundant electronics to command the motors to finish opening the solar arrays. This electronics is contained in the subsystems module bay number 7 on the telescope. And again, this box controls the deployment and retraction of the array wings, and also monitors the status of the deployment mechanisms. Not really known at this time whether the wings were actually, or correction, the masts were actually deployed, or whether it was just an indication problem. In any case, that SLICM, as it's called, it's an alternate procedure, was successful, and the masts are fully deployed at this time. Following that, the verification team went ahead and reconfigured the data management unit, taking it out of bypass, which was a step that was required to enable the tension test for the solar array wings. This is basically a system that monitors the tension on the blankets as they're being deployed, and should that tension exceed approximately 10 pounds, would automatically stop deployment or unfurling of the solar array blankets. Activities of the last hour or so have put the deployment of the solar arrays slightly behind schedule. The orbital verification team, analysts from Goddard, Lockheed, as well as the folks from the European Space Agency and analysts in Huntsville, Alabama, have been looking at the situation and are considering moving up some of the activities that were scheduled to occur later on into the upcoming tracking and data relay satellite path. These activities include potentially deploying the high-gain antennas, unlatching the aperture door, and turning on the magnetic torquer electronics a bit ahead of schedule, which then would put us in a good position to preserve our Orbit 19 release of the telescope. Again, at the present time, that is still being considered, and we're anticipating decisions on that shortly. Other than being somewhat behind schedule at this time, everything otherwise is going very smoothly, and we're continuing to look toward deployment of and release of the Hubble Space Telescope today. At 1 day, 2 hours, 47 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt.
Discovery, we're back with you.
Roger, Houston, loud clear.
The same, Lauren.
This is Hubble Telescope Control Greenbelt. We have confirmation that we are moving forward deployment of the high-gain antennas, and the orbital verification team is now in the process of setting up to send commands to begin that process.